What is actually a diaphragm? A diaphragm is a hollow thin-walled metal disc that is frequently corrugated and expands when a pressure is applied through an opening on one side of the disc. It can be sealed as well. Before sealing, the diaphragm can be emptied, retaining nothing inside. When this done, the diaphragm is referred to as an aneroid. Many aviation equipment make use of aneroids. A diaphragm can also be filled with a gas and sealed at a regular atmospheric pressure. Each of these diaphragms has a specific purpose. A common factor in all of this is that the expansion and contraction of the diaphragm's sidewall corresponds to increasing and reducing pressure. A bellows is a device that connects multiple diaphragm chambers together. When measuring the pressure difference between two gases, this accordion-like structure of diaphragms can be quite useful. As with a single diaphragm, the movement of the side walls of the bellows assembly correlates with pressure changes, and a pointer, linkage, and a gearing are attached to alert the pilot. Pressure sensing devices such as diaphragm, aneroids, and bellows are frequently found inside the single instrument housing that holds the pointer and instrument that are read by the pilot on the instrument panel. As many result, many devices that utilize these delicate and dependable systems are directly reading goddess. However, the diaphragm and bellows are also used in many remote sensing instrument systems. The sensing equipment containing the pressure sensitive diaphragm or bellows is positioned remotely on the engine or airframe. In this situation, it is a component of a transducer which turns pressure into an electrical signal. The transducer or transmitter transfers the signal to the gauge in the cockpit or to a computer for processing and subsequent display of the sensed state. The altimeter, PSI, cabin differential pressure gauge in pressurized aircraft, and manifold pressure gauge are all examples of devices that uses a diaphragm or bellows into a direct reading or remote sensing gauge. The Bourdon tube is the internal mechanism for many pressure gauges used on aircraft. When high pressure need to be measured, the tube is designed to be stiff. Gauges used to indicate lower pressures uses a more flexible tube that uncurls and curls more readily. Most Bourdon tubes are made from brass, bronze, or copper. Bourdon gauges are simple and reliable. Alloys of these metals can be made to coil and uncoil the tube consistently. Some of the instruments that use Bourdon tube mechanism include the engine oil pressure gauge. Remote sensing units can be more practical on twin-engine aircraft, where the engines are a long distance from the cockpit pressure display.